Hello, today we will study derivative. Take derivative by delta method. Okay, or definition. So first one, we need to understand derivative by definition. Okay, by definition, we have, if we have y equal fx, then derivative by definition of y, dy over dx will be equal limit of delta y over delta x when delta x goes to 0, and also equal limit of delta y equal f of x plus delta x minus f of x over dx delta x goes to 0, and y equal fx continuous. Okay, so when we take the derivative by delta or by definition, that means we use this. Okay, that means we use this definition. Dy over dx equal limit of f of x plus delta x minus fx over delta x. Okay, so now let's say we have like y equal x squared. Okay, so now we need to take derivative. Okay, let's take derivative of this y equal x squared by delta. Okay, by delta methods. Okay, so here you have y. Okay, so we need to apply this. We need to take the derivative by using this formula. So first one, we need to find f of x plus delta x, f of x plus delta x, and then now we substitute in here. So we have like half of x plus delta x, and we use this equation. So that means x, everywhere you have x, you should replace by x plus delta x, x plus delta x square, right? Okay, and then you fx is equal x squared itself. So now we have dy. Now we have dy over dx will be equal limit of f of x plus delta x equal this. So limit of x plus delta x the whole thing square minus fx is equal x squared, right? And then divide by delta x. Delta x goes to 0. Okay. Okay, so we need to extend this. Okay, let me rewrite that. Okay, we have dy over dx equal limit of x plus delta x square minus x square over delta x goes to 0. Okay, and if we so see here, if you substitute delta x 0 in here, then we will have undefined. We cannot take the limit of this equation, this function. So we need to eliminate this delta x by simplify the denominator. Okay. Okay, so here, so we just extend this, so it will equal limit of x square and plus 2x delta x and plus delta x square minus x square divided by delta x goes to 0. Alright. Okay, so now we eliminate the line term. Okay, let's say x squared here, we'll eliminate with x squared. Okay, so that, well, now we have this. So finally we have this. So we have limit of 2x delta x plus delta x squared over delta x. Delta x goes to 0. Okay, so 2x delta x plus delta x squared. We can factor delta x out, so we have limit of delta x. Take delta x out, we have 2x. And this one delta x squared, so you have delta x inside. Plus delta x over delta x. Delta x goes to 0. So here, the purple, we need to have delta x on the top, so we can eliminate delta x at the bottom. So when you substitute delta x equal 0 here, it will cancel. You don't have to. You don't have undefined function. So and then you will find a limit of f of y. So delta x, you cancel delta x. Okay, and then substitute delta x equal 0 here. Delta x here equal 0. So that means, so you have 2x left. Okay, so the answer is 2x. So the derivative of y equal 2x squared, y prime equal 2x. Okay. So that we find derivative by using delta method or by definition. Okay, so let me give you one more example. So I just give very simple example, so you know the way, the method to solve it. Then you can solve it more complicated one. Okay. Okay. So when we say take the derivative by delta method or delta definition, then you need to remember that. Okay. You don't have to need to know the take limit of this one. You have to remember. You want to know what delta x goes to 0. Okay. Okay, let's say take the derivative of y equals square root x. Okay. So x greater than equal to 0. Okay, derivative or the slope is the same thing. Okay. Derivative or slope of one equation, slope of one function is slope y prime, it also equal derivative. Okay, so if they say find the slope of y equals square root x, or find the derivative of y equals square root x, it's exactly the same thing. So let's say we have y equals square root x. Okay. Now we need to substitute, to use this definition, limit of f of x plus delta x minus fx, delta x go to 0 over delta x. Okay, so we need to substitute that. We have limit of f of x plus delta x. So everywhere has x, you put x plus delta x. So we have square root of x plus delta x, and fx is equal square root of x. Right, and then it's still delta x still divided by delta x. Delta x goes to 0. Here again, if you substitute delta x 0 here, it will undefined. Okay, so somehow we have to eliminate this delta x. We need to eliminate this one. Then you can find the limit of this. Okay, and then you will find the derivative of the function given, y equals square root of x. Okay, so now how do we do this? Okay, so in this one we have the square root minus with square root. So all you have to do, we have to multiply with exactly this 2, but you need the plus sign. That means you apply this a minus b, a plus b equal a square plus minus b square, a square minus b square. So you need to get rid of the square root sign. Okay, in order to do that, you remember you have to do that. You have, okay, square root of x plus delta x minus square root of x delta x. Okay, if we multiply, exactly the same thing. Square root x plus delta x plus square root of x. Okay, so that means a minus b, take a plus b right here. Okay, and then if you multiply that on the top, then you just divide exactly the same thing at the bottom. Okay, so nothing changed. Okay, so then we combine the two terms. So this means, so we have that limit of limit of these two terms, a minus b times a plus b. I mean a square, this term square. Square, right? Minus b square, b is square root x minus x square, right? And still have delta x, and this new term is square root x plus delta x plus square root x. Okay, so square root of x plus delta x square, it will go x plus delta x, the square root sign gone. So we have like x plus delta x, and this one square root square is equal x. X with minus sign is minus x over delta x square root of x plus delta x plus square root x. Okay, x minus x cancel. You have delta x on the top. So delta x over delta x times with square root of x plus delta x plus square root of delta x cancel delta x. So we have the limit of 1 over square root x plus delta x plus square root x. Okay, we already have delta x go to 0. Delta x already cancel with delta x right here. See? Delta x. So it's cancel out. So now we can, okay, we can replace delta x go to 0 here. When delta x go to 0, this will be equal 0. So still have square root x and plus square root x. Okay, so square root x plus square, okay, 1 square root x plus square root x 2 square root x. So the final answer is 1 over 2 square root x. Okay, so or you can multiply. You can write in another form. 1/2 and square root x equals 1 over 1/2. 1 to the power 1/2, and then from the bottom you put it in the top, so it will be equal x minus 1/2. Okay, so that's the final answer. Okay, let's okay, so now we will find y equals square root x. Take the derivative, y prime will be equal 1/2 of x minus 1/2. Okay, using delta method definition. Okay, so it's very easy, right? Okay, let's find one more example. So let's find the derivative of y of fs equal let's say s plus 3. Okay, so we apply the by delta method. So now we apply by delta method. We have definition limit of f of s plus h plus delta s minus fs divided by delta s. Delta s equal to 0. Always use this definition. This is the derivative using definition, using delta method. So limit of f of s plus delta s minus f of s divided by delta s equal to 0. Okay, and also f of s continuous. Make sure it's continuous in the domain. Okay, so here we have like fs. Okay, we just substitute fs plus a. So here you limit of s plus delta s. So that means s plus delta s. Whenever you have s, you divide the s plus delta s right here, and then plus 3, and then minus f of s. The minus of this one, minus f plus 3. Then the whole thing divided by delta s. Delta s equal to 0. Okay, so here we have like this one s plus delta s, right? This one f of s. So we eliminate similar term. So you have s plus delta s plus 3, and here is minus s minus 3. Then you have limit of, okay, open the parenthesis, s plus delta s plus 3 minus s minus 3. The whole thing by delta s equal to 0. Okay, so you cancel s with s, 3 with 3. So on the top we have delta s, and the bottom we have delta s. So delta s divided by delta s equal 1. So limit of s plus 3 delta s go to 0. Limit of f of s derivative, derivative of f of x equal 1. Okay, so derivative of that. So derivative of, you can write like that. Derivative, use a prime right here. S plus 3 prime equal 1. Okay, we can stop here. Okay, so it's pretty easy. For the more complicated problem, we will do on the exercise next time. Okay, and right now we just learn what's necessary to do exam fast, because probably most of this we don't apply, and most of you don't apply it much in life. Okay, but you need to understand the basic of derivative. Okay, derivative by delta, by definition. Derivative is the difference, the change of y of one variable to the other variable. The ratio of the difference of delta y of y over delta x of y variable to extra variable, to one variable to the other variable. The difference, the change, okay? The change of the difference, okay? So this one you have to always remember for sure. So you can do exam in your class, okay? Okay, so now the first one we just study today, we just study take derivative by delta method or definition. Okay, so today is okay. So again, dy over dx will be equal, okay, y prime or f prime x. Okay, here's summary, so it will be equal limit of f of s plus delta s minus f of s as delta s go to 0, 1 over delta s. Okay, derivative here, you can call it slope derivative of a function or slope of the function. Both the same, okay, slope of the function. Okay, so that's it. I see you next time, and to help you understand this take derivative by delta method. Okay, bye.